So there should be a video on this on YouTube, but I will be posting it on Blackboard for you guys. You want to follow this video. It'll walk you through. Oh, let's see if I can find it. It should walk you through the process of creating static routes. So you guys will have a video on Blackboard that'll just go through this. Let me get that. Come on, let's just grab that.
We gotta get you some more views, Nick.
Oh yeah, could you guys help me out? I get so depressed.
You need to start adding like a
Nobody loves me.
Why don't you do this anymore?
Shameless plugs. All right, this plays. I want you guys to pay attention too that at the beginning of these timers, you know, when you open them up, the packet tracer will start it from 0. By the time I get done this video, it's like 2 hours and 15 minutes, and then it takes me another. I believe I started this one last night from 7 o'clock, 6 or 7 to 2 o'clock in the morning, just so you guys had it. But in any case, watch over it because it will show you guys how to throw routers on each of these LANs, how to configure them like we did in lab again. But obviously you guys have it with the whole screen. It'll go through the configurations. The other thing it'll do is it'll show you how to connect the routers to a switch and how to configure the routers to have static routes. Okay? You good about that? What I would like to do today is if you guys download this file, it should be exactly where that video would be having you take off on and doing, but rather instead of using static routes, we'll be using dynamic routes. All right, so everybody has this video? Oh, video. Sorry, guys. I only got 4 hours of sleep last night. Everybody has this file, right? So you're going to log on to Blackboard, go to week 6, download the file called multi-access WAN. All my LANs are properly configured. So if I hit the fast forward button, these lights should all go green. And every one of the devices on a local area network should be able to ping or communicate with each other. What's not configured are the public sides of each of these routers, as well as they're not connected. So why don't you guys spend some time connecting these routers together using a switch and using the FA01 port or interface of the routers to connect to the switch. I prefer that you use FA0/1 of the switch to R1, FA0/2 of the switch to R2. Getting the idea? So just go ahead, drop the switch, connect them. And if you remember from yesterday's lab, go ahead and configure them. I gave you the network address for the WAN as being 1.0.0.0.
There's so many goblins.
Now remember, we're using the straight through cables to connect routers to switches. The only time we use crossover cables when we connect like components. Like when we connect a router to a router using Ethernet, we would use a crossover cable. All right? So now that I have them connected, what I'm going to do is click on one of the routers. And what should I make R1's public interface address be? So I click on the config tab. I'm going to come down here to the FA0/1, so the fast Ethernet 0/1. And of course, I'm going to need to turn it on. But the question I ask is, what should I be putting in here for the IP address and the subnet mask? Okay, I like the fact that you said 1.0.0, and the 254 would work. But because you're assuming that this is the gateway, but remember this is actually the public side of the router, right? And where Andrew got the 1.0.0.0 information is because I wrote it on the packet tracer workspace. We good about that, folks? But what I would like to do, and Andrew used would have worked. I'm just looking at management purpose. This is R1, right? So what if I just make this one 1.0.0.1? And then over here I would make this one what? 1.0.0.2. Folks, you got to try to meet the logical world with the physical world. You and I see things physically. And so when I start looking at these routers, and I know this is on floor 1, and this is on floor 2, and this is on floor 3, and this is on floor 4, try to create an addressing scheme that's easier to memorize. Because if it's easy for you to memorize, it's going to be easier for you to troubleshoot and maintain. So I'm going to go back to R1. And it's imperative that we all follow the same addressing, because when I start saying this is what you want to type in for the next hop address, and you do that and it doesn't work, that's because what you set up for your router isn't what I set up for my router, and hence you have to change your configuration. Now when I click into subnet mask, it's going to be 255, then all zeros. And now I'm going to do the same thing with R2. Click on that, click on the config tab, and then come down here to the FA 0/1. And if you're just joining us, please go on to Blackboard, go to week 6, download this file. It's what we did in the lab. We're just trying to create a wide area network using Ethernet. So I'm going to turn this fast Ethernet 0/1 on. Go to the IP address. It's going to be 1.0.0.2. And then I'm going to do the same thing with R3. Now, folks, if you're feeling rusty about this, once again, I'm going to encourage you guys to go back and watch that video I showed you earlier. Just go through this, rehearse, practice, and practice, because from here on out, you'll be doing a lot of this type of configuration. Many LANs connected with many WANs. And if you don't feel comfortable doing it, you're going to get lost in the details and not in the theory. Now, in the interest of saving time, I'm going to fast forward to this. Eventually, you guys should have all green lights in the WAN network. Would PC0 be able to ping like PC7 now that I configured those interfaces?
Yeah.
Unfortunately, I haven't taught those routers about the different networks. Remember, you have to ask yourself, what networks does R1 know naturally? What were they born with, if you will? When this router boots up, what network will it know? Evan?
The first network
LAN 1, and what else?
The WAN.
And the WAN, because they're the two directly connected networks. That means any information that's destined to go to this network will work, or any information that's destined to go inside this local area network should work. However, any information that's destined to go to these other networks will not work, because when the packet comes into this router, it's going to be looking for a match in its routing table, and one's not going to exist. Now, I showed you a command yesterday in class on how to look at a router's routing table, and that is simply if you click on the router, you got to click on the CLI, the command line interface. In my prompt, I have R1 config-if, and what I'm going to do is I'm going to hold the control key and hit the letter Z, and then I'm going to hit enter. And what that'll do is it'll take me back to privilege mode. And what's that?
Would it have a default route before you configured it, or do you have to configure it?
You have to configure it with a default route. No different than you have to configure computers to have a default gateway. And the default routes are nice because they're like catch-alls, so you don't have to manually configure everything. But you do have to actually set that up. Let's try doing a show space IP space route. And your instructor screwed up. So Andrew, you would be correct. It does have 3 static entries in there. Now let me go back, and that's why I do those show IP stuff. I got carried away this morning. 4 hours of sleep, folks, sorry. We're going to delete those, because what I thought I did was I only left these 2 entries in there. Mental note. All right, let me close out of that, and let's go back to R4 and do the same thing there to see if there's entries in that one.
Yeah, there is.
There is entries in that one, so you're right. It would work now. Thank you, Andrew. Nothing like telling a student he's a moron and shows you you're wrong. Here we go. Let's and if I do the show IP route, and yes, they are those, and you can see the S's are there because I statically configured them earlier. Let's destroy those entries. Sorry about that. So let's go to config. Come over here to the static button. And now click on each of these little routes that are in this network block and click remove. If that ever happens in the future, just let me know, Andrew. Well, Nick, my routers are configured. Are you sure you deleted them? And do the same thing with R3, R2, and R1. I apologize, guys. Nice little exercise on how to remove static routes.
That was pretty fun. It's like, sweet, I'm not going to have to do that.
Well, we don't want to do static routes anymore, right?
Just get excited because he's like, oh yeah.
Yeah, it's filled out.
Mine works, woohoo. I don't have to do any more
Tell
work.
anybody.
Hopefully mine's the only one.
All right, now, Andrew, will PC0 be able to communicate with PC7? Not since we deleted the static routes. That's right. Remember, today's class is actually getting away from static routes and learning about dynamic routes. Fortunately, the only dynamic route we're going to be learning is called RIP, the Routing Information Protocol. And what that protocol does is tells these routers how to exchange their routing tables. And it's really neat because it's going to allow me to develop a network that's scalable. Think about this switch right here. How many ports am I using? Only 4, correct? But how many total ports does this switch have available to it? It says -24, so I'm assuming it's got 24 total ports. So I have 20 more ports. That means if I want to add more floors or more subnets or other networks onto this particular topology, I want it to scale naturally. I don't want to have to add another 3 routes per each router I add. That would be a logistic nightmare. So we're going to switch the process from static to dynamic and teach these routers how to exchange routing tables. So let's click on R1, and you guys are going to love this. Not bad. When you get into Cisco 2, though, you'll hate this. Dynamic routing protocols, there are some of them that are easy to implement, but they're hard to troubleshoot. I mean, you're teaching the router to have a mind of its own. And when that starts happening, it's going to learn about routes that you're wondering, where the hell did you get that from? So it's great that we're only giving you guys a taste of dynamic routes. And the best thing about it is you actually get to do it using the graphical tool. And Cisco 2, you're all about the CLI. And you'll learn what that is at the last chapter. All right? So let's click on the config. Let's come over here and click on RIP. Like I said, that is a dynamic routing protocol. Now this router knows about 2 networks. What you need to do is tell the router that those 2 networks that it knows about, it has to share. Okay? The other thing you're telling it to do when you add those networks into this table is you're also going to be listening through those networks to learn about other routes. Translation. What network does this router know about that all the other routers don't know? But remember, I'm on router 1. What's that network? The 10.0.0.0, right? So I'm going to come over here where it says network address, and I'm going to type that in, 10.0.0.0, and I'm going to click add. By me putting that into this network address block, I am telling this router that I want you to share this network with other routers. Okay? What network does this router know about that the other routers are connected to? We just got done configuring those that wide area network. So we're going to update this one and add a new network of 1.0.0.0. Think of this as like the community center. You have something to offer the community, but everybody has to meet in that center for you to exchange that. Does that make sense? I want to tell everybody about my private network so they can find a way towards me, and I'm going to do it out of that network. All right, let me close out of this.
So there's no way to indicate, like, it doesn't matter which one's the central?
There isn't going to be any central. That's another routing protocol, like OSPF. But with this one, all we're just saying is, and we don't really want a central location. The idea is if a router goes down, we can find other pathways to it. We good about that? In fact, next week's lab, well, there is no next week's lab, but next week packet tracer that we do online, you will see some routers in series. and how we can create alternative routes. So we're going to do the same thing with R2, but remember, when I say same, I don't mean exactly same. I should say similar. We're going to go to R2, click Config, click on RIP, and then we're going to type in the private network that that router represents, 20.0.0.0, click Add. And we're also going to put in the public network that that router is going to use to exchange information. And after I get done doing that, I'm going to do the same thing with R3. This one's 30.0.0.0. And then I finish up with R4. Notice I'm not telling it exactly where to go to. All I'm saying is share your private network to any router on this public network. That's it. Before these devices can communicate with each other, we need to have what we call a converged network. That means every one of these routers have to have a similar routing table. If we don't have that, we can have some communication problems, whether endless loops or just drop packets. So what I'm going to do is I'm just going to click the fast forward button a few times, just so I know that the routers have converged successfully. I just can't tell that, and I won't be able to fast forward time in the real world. So I'm going to use that show IP routing table command as well. So I'm going to go back to R1 and click on the CLI. Hold the control key, hit the letter Z, and then hit enter. And I'm going to type in show IP route and hit enter. Now I have 3 of those entries back again, but this time instead of saying S, they say R. Anybody want to take a guess what the R stands for? RIP. RIP, because that was the protocol that we used. Now, if I close out of R1, and click on PC0, go to the desktop, click on the command prompt, and type in ping 40.0.0.1, I should have successful communication. Now the first the first reply might time out, but the other ones will build up. Remember, it's got to build its ARP table as well. A little simpler, right? You went to 4 routers, you just added 2 networks per each versus the 3. Let's see the real benefit. Let's close out of this. And I want you guys to create another network. We're going to call this local area 5. And what do you think the network address is going to be for this new network? All right. There we go.
I'm sorry, man.
Just make sure when you go home you show your mom the YouTube video so she can be proud of you that you got that answer right. All right, so let's go down here. Click on router. Click on the 1841, and I'm just going to drop it between LAN 3 and LAN 4. I'm going to add a switch underneath that router. And then I'm going to add 2 end devices. One here. And now I'm going to connect each of them accordingly. Whoops. Now remember, when I click on the router, I'm clicking on the fast Ethernet 0/0 for my LAN, but I'm also choosing this port 24 of my switch. And that's just me trying to match the logical world with the physical world. What I tend to do for my default gateway is I'm going to make this the last usable space, so it's going to be 50.255.255.254. So let me write that up on the board for you so you guys have it. Let's put it right over here. So the default gateway is going to be 50.255.255.254. So let me configure this one. This one's going to be my second PC. Bless you. So this one's going to be 50.0.0.1 subnet mask. There we go. And if you guys have any questions, just raise your hand. I'll come over to visit you. And do a total configuration when it comes to the router. I want you to configure both the FA interfaces and also turn on dynamic routing. And after you do a total configuration, just fast forward time, and then do that show IP route on any router, and that every router's routing table should have that new entry for the 50 network. And like I said, just raise your hand if you guys need some directions. I don't know how helpful I'm going to be. After all, I've been making some of my own personal mistakes. So we have those taken together. I'm actually going to ping just to verify that these are working. There we go. While you guys are doing that, how's it working out for you folks? You guys able to get the networks to communicate with each other? If not, don't have a problem. Raise your hand. I'll be over to guide it out. This process is a little tricky. You only get better with it through practice. And with these videos, you guys can actually guide yourself through it over and over until it feels pretty comfortable. Do you see the benefit with dynamic routes? As I add a new network to it, all my other routers are being aware of this new change. Michael. Yep. Yes. So, okay, it says, all right, let's go to, you are on PC 0, right? Okay. Let's click on R1 for a second. Let's click on config and click on RIP for me. Very good. Okay, let's close out of that one. Let's click on R5. Yep. And that looks good. Let's go to CLI and let's hold the control key. Yep, hit enter. Will that work without hitting enter? There you go. I hate the fact that it has a latency like that. Okay, so we don't have, all right, so now I gotta check the interface. So let's click on config. Let's click on FA0/1, and it's not configured. So it's unable to send their routing table because it doesn't have an IP address. So that one's gonna be 1.0.0.5. Oops. And then, yep, now close out of that. Let's hit the fast forward button. And what we did is we just configured that side of the router. So now that these can all communicate with them, because every host, because you can consider these interfaces as hosts, have an IP address. All right. So now let's go back to PC0 and ping that. Ping first. I do that all the time too. Can't wait till they can read our. Oops. Feeling better? Oops. There you go. Dot. There you go. And all right, but we're getting a different one. Oh, are we? No. All right, so it either hasn't yet received the updates. Let's go back here to this one. Let's click on R1, and let's go to CLI. Control Z for me. Hit enter. Do a show IP route. All right, so it knows about those. Let's go back to R5. And let's click on RIP. And let's click on each of those and hit remove. And we're going to add them back again because now that we have an interface. Yep. Click it. And let's see, that'll update its table.
Fast forward.
Yep, you got it. Do it a couple of times. Yeah, okay, so I'm seeing some lights blinking. Now let's go back to R5, and we're going to do a show IP route. So go, yep, Control Z. Okay, so let's go check the other interface of that router. Let's click on config, fast Ethernet 0/0. So now we need the, so this is going to be 50.255.255.254. And click on the subnet mask. Let's close out of that so I can show you what we configured. Now we configured the private side of that router.
Right.
Let's go on PC8, and I want to check to see if it has a gateway now. Let's click on, and now, yep, there you go. So what you had was you told it that you have a gateway, but you didn't have a gateway.
Gotcha.
Now you made the gateway by configuring that router as such.
All right.
So let's close out of that. Let's go back to the R5 router. Let's do a show route. There we go. And it still hasn't learned that yet.
Still getting more hits here than we used to though.
Yeah, yep, you're getting, because now you just turned on both of those networks because you're directly connected. Let's fast forward and see if that will build up. Well, they should have. Yep, let's keep on going. All right. Now let's go back and run that command and see if it, if you hit the up arrow, it should do it for you. There you go. Okay, let's go back to config. We might have to delete those entries and put them back in. Yep. Okay.
Fast forward again.
Yep. All right, now let's go and see if they are communicating.
Nope. That's
Yeah, yeah. Unfortunately, it always does your last previous
right,
command.
right. Even if it's a
Oh, show. Sorry. Still not communicating. What else are we missing on this one? We know. Let me make sure that these are correctly. Let's go to config, verify that. Click on FA0/0, 250.255.255.254. Good. Submit. Yes.
Could I have plugged this in backwards?
Yes, you might have.
So
Yes.
reverse the data here.
Well, let's just close out of that. That's a good point. Let's hover over the green dots. Hover over this green dot there, and that'll let me know. And you did. Okay, so good job. Click on that green. Oops.
The dot.
Yep. Click on the green dot, and then hit escape when you do that. No, just hit escape, and then do the same thing with that green. And now click back on the router. Whoops. Close out of that. Sorry, I didn't want you to escape, but click on the lightning bolt. Then click on the straight through. Click on switch, do port 24. And then click on the router and do FA0/0. Then do the same thing. And very good. And now you can see why we want to manually configure them, because we can select them. Hit the fast forward a few times.
Manually configured it.
Just, yeah, keep on doing that fast forward until it builds up its ARP table.
All right.
Okay, now let's try, click on R5, go to CLI, type in, well, hit enter. Control Z, now type in show IP route. You got it. Good job.
Thank you.
Should be able to work. Ryan, you had a question? Which ones? Any of them? Okay, let's go to real time. Yeah, we can close out of that. We don't need that. Let's go to R1. Let's go to the CLI. And hold the control key and hit the letter Z. Hit enter. Type in show. IP, yep, route. Hit enter. All right, so what I can see is right now it's not receiving any information or sending it. So let's click on config. Let's go to RIP. We have that. That's good. Let's go to the FAs just to make sure that they're correct. That one's right, and let's go to the next one. All right, make that 1.0.0 right above it, the IP address. 1. So it's going to be, yep, there you go. Close out of that one. Go to R2 for me. Let's check the FAs. So FA0. And that one's right, yep. Click on that one. And that was what you're happening. You're having a name conflict. You're using the same stuff. So make that zero. No. It's got to be on the same network. So make it a 1.0.0.2. Because they can't communicate unless they're on the same logical network as well. Close out of that. Go to R3. Go to the FA0/0. That's right. Now go to 1. Replace that so it's 1.0.0.3. Because remember, this network here is the 1.0.0.0 network.
And I always get them conflicted with these networks.
Well, you're getting these hosts, these interfaces here all conflicted. So let's do R5 and click on the FA just to verify that one. That's good. Let's go to the 1. Make that 1.0.0.5. Right, let's close out of that. Let's click on, there we go. Looks good. Now replace that one so it's 1.0.0.4. All right, close out of that. Let's fast forward the time. Keep on going just a few more times so I feel good. All right, let's click on R5. Go to CLI. Hold the control key, hit the letter Z, hit enter. Do a show IP route. All right, so we still haven't got any information sharing there, but that could be because let's go to RIP. Yep, so there we're going to do the 50 network. You got it. And then we're also going to do the 1 network, so let's click back on that. Now let's close out. Do the fast forward again. Now click on the R5. Go to the CLI. And then hit enter. Or sorry, Control Z. Hit enter. And do a show IP route. There we go. Everything should work. All right, folks, how did everybody else do? Unfortunately, we won't be spending our time doing a lot of dynamic dynamic routing. And the only reason that is because Cisco 2 is all about dynamic routing protocols. Network Fundamentals just gives you a taste of every networking concept. Then we go explore just that concept in another book, if you will. All right. So when we get to like chapter 7, 8, and 9, you guys will be seeing that in another section. Another Cisco book called LAN Implementation. Is everybody somewhat comfortable with this? Like I said, just watch the videos, practice with them. The concept is what I'm trying to really drive at to you, is that in order for a packet to be transmitted or delivered from network to network to network, each end device plus the intermediate device known as a router will have a routing table. And so what I'd like to do with you guys now is show you that process again, but using binary. So you want to get out your notebook paper because we're going to talk about some binary conversions just so you guys can get comfortable with this concept known as routing. I'm going to draw a just simple, quick, logical topology. I had the 10.0.0.0 network that was plugged into R1. R1 was plugged into a switch. R2 represented the 20.0.0.0.0. Then I had R3, which represented a network, the 30 network. And then I had R4, which represented another network, which we called the 40 network. Before we move on, we need to get one thing straight. Devices on a network must have the same logical network address. Okay? These routers can be considered a host per each device, if you will, of this network. What I'm trying to say is that these routers have two interfaces. One is one side of the door, and the other is the other side. The side that represents this network better have the same network address as each device on that network. The same can be true about this side. The side that represents the public side better have the same network address as all the other devices. What happens if they didn't? And the question is, why wouldn't it work? Because that's where we're at now. We can't settle for the 5-year-old answer, the sky is blue because it is. We need to wonder why it is. We need to basically create a scientific approach to analyzing what makes the sky blue. In this case, I don't care the sky's blue. What I care about is, why doesn't it work? Where in that rule, the list of rules, those protocols, it's saying this is why it doesn't work? What process? Let's take a host. Let's take this network and let's zoom in on it and ask myself, well, how many total addresses can this network handle? When it comes to a particular network, we're going to be faced with these three types of addresses. And all networks must have that, including this WAN. Must have a network address. In this case, my network address is the 30.0.0.0. I must have a broadcast address. Does anyone want to take a guess what the broadcast address is for this network?
3255.255.255.
Guess. Andrew, how'd you come up with that?
Because it's all ones.
It's all ones. What is all ones? The octets, because the 30 isn't all ones, right? More importantly, the host part has all ones in it. Why is my network address 30.0.0.0? Well, if the broadcast address is when you have all ones in the host, what do you think the definition of a network address is? When you have all zeros in the host. Remember, an address can be broken up into two parts. The network side of it and the host side of it. Together they form what we call an IP address. Where do we draw that line at? Up to this point, you guys have been learning about classful addressing. And I said that if a number begins, if the first octet falls anywhere between 0 and what number? 127, right? It's from 0 to 127, including 127. Then it's a class A. And I told you that the class A would have a subnet mask of, let me color code this, of 255.0.0.0. We good about that? This is the subnet mask. And what it's used for is for an end device to determine where exactly the line is drawn between the network part and the host part. So if a network consists of three types of addresses, a network address and a broadcast address, then what's in between those? What must every network have? Boy, you guys are going to go home and show your parents your video. Look how smart I am. Look how smart I am. That's me. There you go. There you go. Do we have to actually have, well, let me ask you, how many host addresses do I have in this network? So, question is, how many hosts, and I'm going to put in parentheses total, can LAN 3 support? Now, we are moving away from physical networks, and we're getting into logical networks. So don't be cute and say, well, Nick, if you have a switch and all it has is 24 ports, then all it can handle is 24 devices, right? Well, couldn't I take another switch and hook it up to that switch, and now I'm up to 46 devices?
Like 16,500,000.
Well, how'd you get that number?
Because you multiply all the possibilities together, so there's 255 options times 255 times 254.
Yeah, I like that, but you're off by the last one, not 254. You would say 255.
55?
Yep.
I thought the top and the lowest were used.
You subtract afterwards.
Oh, gotcha.
Very good. But can I teach you another formula? Because this is a probability. If you had a probabilities or a stats course, you definitely do that. What he's doing is he's going down through this and multiplying by the different possibilities, different combinations, right? And that works out great. But like I said, I want to move away from the decimal and get into the binary. And here's the formula that you guys want to know. We take 2. And why am I taking 2? What am I working with? We write it in decimal because it's easy for us to write. Because I do not want to waste my time writing down 32 zeros and ones per each network address or per each host. We good about that? So we write it in decimal because it's shorthand. But what we really want to do is see this in binary. What's the base for binary? 2, right? So we take the base and we raise it to the number of bits I have available. How many bits do I have available for my host? Because after all, the question was, how many hosts total can LAN 3 support? So I have 24 bits because I have 3 octets here, right? Each octet is 8 bits. So if I take 2 raised to 24, I'm going to get about 16.8 million. Technically, it's a little bit less, but and Kellen got the same answer by just taking 255 times 255 times 255. Now, this would be the right answer for this question because in parentheses, I said total. What if I changed the word total to be called usable? Then I do what with the 16.8 million? Distract you from it. All right. Do you think Bill Gates worries about pennies, let alone dollars? He probably doesn't even worry about $1,000. I'm sure he uses that as toilet paper. But do you think we need to worry about 2 addresses when it comes to Class A when we have 16.8 million? No, but you know what, folks? I don't want you to get lazy. I don't want you to forget the difference between total host range and usable host range. Because we will get down to smaller networks, and then it really matters. Why can't I use my network address? Why is that not part of the usable range? But I should write 16.8 million minus 2. Why am I subtracting the network address and the broadcast address from my usable range? What does the network address represent, and where do we use it? You guys just got done using it, right? We just spent like 30 minutes doing this in class. The routers use them, right? The routers don't want you guys to put in 16.8 million entries in its routing tables. Why not? Why would they? What would be the problem if they had 16.8 million entries, one per each host in a network? Yeah, it's going to take forever to process because remember, every packet that comes to the router, even if it's the same another packet destined to the same network, it follows the same steps. Strip the frame information off of it. Grab the destination IP address. Calculate the network address. How do they calculate it? Because remember, if you look at an IPv4 header, there is no subnet mask that's included with it. Where are the subnet masks included? When we did our next hop address, what did you have to supply with the network address and your routing table? There was 3 things you guys had to put in there. One of them was the subnet mask. And it was a subnet mask of the network you're trying to teach that router. Does that make sense? That means your routing table is going to have some kind of subnet mask in there, and every packet that comes in on it is going to AND it with each subnet mask to come out with it. Could you imagine 16.8 million entries? Now, router processors are becoming faster and faster. Thank you, smartphones. I mean, we're using those ARM processors in more devices than just smartphones. And they're pushing this. Back in the day, routers only had like 33 megahertz processors. And people are saying, well, that should be good enough. Why? It's just processing text. And we're going to optimize this thing. And instead of putting out 16.8 million entries in a routing table, we'll say, hey, this address right here represents all 16.8 million entries. Question. I said earlier that 2 devices on the same network can't have the same IP address, so ultimately they are allowed to have the same network address, correct? Could I apply that theory with this? Can 2 different networks have the same network address?
Yeah.
Let's think about this for a second. If I want to send a packet out and both these networks have the same network address, but a switch doesn't do any copying.
What, does just drop it?
Well, the switch just drop it or release.
You get what we call flip-flopping. Sometimes it might go to this one. Sometimes it might go to that one. It all depends what's in the routing table, correct?
Would the segments get messed up too? Like would half the data go to one and half to go to another?
That's exactly what will happen.
I didn't know if like a full file transfer would happen.
What will happen is if your routers are configured with a certain protocol, it will do load balancing. It'll see that it has 2 equal paths going to 2 separate networks of the same network address, I should say. So it's going to be 2 separate paths going to the same network, logical network, even though you guys are seeing it as being 2 physical networks. And so half the message will go to this one, and the other half will go to that one. Now you guys are telling me, but Nick, my network address at home is 192.168.1.0. And I'll say, hey, mine is 2. And somebody else in this classroom will say, yeah, mine is 2. And so part of Chapter 6 reading is going to cover what we call private addresses. In fact, write these down so you guys have them, because part of troubleshooting is to understand these. Class A's private network address is going to be, so we're going to do Class A. It's going to be 10.0.0.0 all the way up to 10. Anybody want to take a guess? No, we're not going to take the whole class. We're only going to take one network block out of that class and lock it up as private. And it was a logical guess, but we're just going to make this one private. And what I mean by private is they belong to these local area networks, and I can reuse them because I'll teach the routers to translate them using what we call NAT. Network Address Translation. Have you guys heard of NAT before? Especially when you're playing your games, your Xbox might say, hey, you're behind a NAT firewall. And this is the reason why they do it. They need to translate these network addresses into a public address. And by doing that, that allows multiple devices on the same private network to have internet access. Class B's private address is a little goofy. Next week, I'll show you guys how to look at it in binary and make sense out of it. It's going to be 172.16.0.0 all the way up to 172. I got to try to remember this one. I think it's like 37.255.255. I'll have to check that again. Class B is always goofy because it doesn't go a full spectrum, if you will. I think it's 37, but it could be 38. If it is, I'll update you guys later. Class C is 192.168.0.0 all the way up to 192.168.255.255. And this is why many of you guys can tell me that somewhere in your home network you have an address that's 192.168.something.something. Is there anybody in this classroom who hasn't experienced that? If they're not sure, just hold the window key, hit the letter R, type in CMD to get to your command prompt, and just type in ipconfig. More likely than not, the first 3 octets of your IP address is going to be 192.168.something. And you have a private address. Why did we come up with this concept of public and private? Is because this allows me to reuse this stuff over and over and over. But in order to reuse that, I have to have a piece of service running on my routers that will translate this. And when I add a new service on my router, what does that mean about the latency? How long will it take to process it? Will the time increase or decrease? It should increase, right? But it gives me some better benefits. And that is, what I'm allowed to do is I can reuse some of these without losing IP addresses. Before we came up with this concept, there was a big scare in the 90s that we were going to run out of IP addresses. And so they were on to a new version. And now you guys know that version as IPv6. There is another potential scare that we are going to run out of IP addresses. China is just getting onto the market when it comes to the internet. I mean, you guys can watch the war that Google and China are waging against each other. And once they get their devices on to this public network, we're going to be moving to V6. In fact, part of these companies are already doing that, like Comcast and Time Warner. Will we be doing it locally on our networks? Probably not. Our routers will probably handle the translation as well. All right. Today's Wednesday, right? So I won't see you guys until next week. A week from today, Wednesday, you guys will have a Cisco assessment. Please stay tuned because I'll tell you guys how to convert these numbers into binary and how to make sense out of these private addresses. All right, I'll see you guys later. Have a good weekend.